Hi everybody. This is the last few of the problems from our note packet that were the type where we needed to create an equation and then solve it. So like the number value problems and the direct translation equation problems and some of those interest rate problems. So these are starting on page 12. So I will go through the ones that we did not do in class. So if you haven't tried them yet, then you might want to try them first before you watch this video. Okay, so the first one, so 6 less than a number is 10. Find the number. All right, so I'm going to use my red there so I can figure out where my equal sign is. That's going to be the is. That's that. And then the right-hand side is just the negative 10. That's the only thing that's over there. On the left, we have some translating to do. So we need to have a number, so that's going to be our variable, whatever variable you'd like to use, and 6 less than that. So that means I'm starting with n and I'm subtracting 6. So this is the one that tells you subtraction, but also tells you that you have to switch the order, because I start with the number, but then I take 6 away. And then from here, should be a fairly straightforward solving of the equation. Add 6 to both sides. So n is negative 4. All right, next one here on page 12. So twice the sum of a number and negative 2 is 16. Find the number. All right, so there's my equal sign. And I have just 16 on the right-hand side. And on the other side, we've got twice, which is going to mean multiply by 2. Sum, which of these two things, which tells us addition. And we need to figure out how all of that is going to get configured here. When we use sum here to describe this subtraction, it's implied that we already did it. I'm sorry, for the addition here. Sorry, addition, not subtraction. So when we say sum, that's the answer to an addition problem. So the implication is that we already did the addition, and this is the result. So if that's the case, then that phrasing implies parentheses. So if I use x for this one, so it'd be x plus negative 2, because that's the sum of a number and negative 2. And then I'm going to do twice that. So that's one of those words that means not only multiplication, but what number we're multiplying by. So we're going to have a 2 on the outside there. And then at that point, we've translated the equation. We're going to multiply that 2 throughout. So we'll get 2x plus negative 4 equals 16. Add 4 to both sides. 2x equals 20. And divide both sides by 2, x would be 10, or whatever you used for your variable there. All right, and we are going to flip to the following page, and the bottom one on page 13 with eBay and Amazon. So this is page 13, the bottom. Two of the largest internet retailers are eBay and Amazon.com. Recently, the estimated U.S. sales of eBay were 0.1 billion less than twice the sales of Amazon.com. Given the total sales are 5.6 billion, determine the sales for eBay and the sales for Amazon.com. Okay, so this one definitely has a lot of information that we've got to tease out here. So first of all, let's just kind of get some basic information before we start jumping to translating into symbols. So the first thing is that eBay sales were 0.1 billion less, so that's that subtraction, but we're going to flip-flop the order, than twice the sales of Amazon. So 2 times Amazon's sales minus 0.1 billion is going to be the amount that eBay is going to have. Okay, so twice Amazon's sale, 0.1 billion less than twice the sales of Amazon will be the estimated sales for eBay. Total sales are 5.6 billion. So in other words, that means eBay plus Amazon is going to equal 5.6 billion. All right, and you're saying, okay, that's all great, but, you know, how am I going to get this into a shape with a single variable so I can solve it? All right, so what I would recommend is I would probably use a variable to represent Amazon's sales, and I'm going to use A just to help me remember that it's for Amazon. So Amazon's sales. Shoot, this pen is okay. All right, so Amazon's sales will be represented by A. So then that means that eBay's sales, we can go over here and say, all right, well, that's going to be 2 times A, because that's what I decided to call Amazon sales, minus that 0.1 billion. And that's eBay. So now we have a way to represent Amazon sales, and then an expression that gives us eBay's sales. So if I take those two pieces, I can now put those in this second equation that I was putting together here, where that the total sales, so total, remember being one of those words that tells us addition, that when we add the sales of Amazon and eBay together, I'm going to get 5.6 billion. So eBay is 2A minus 0.1 billion plus A equals 5.6 billion. And then you could put this in parentheses if you wanted to emphasize to yourself that that entire thing is the sales for eBay. It makes no difference in our problem here because we're just going to be, taking those parentheses away to go ahead and add like terms. So I do have a 2A and a 1A, so I'll have 3A minus 0.1 billion equals 5.6 billion. And that means we'll add that 0.1 billion to both sides. And it can get a little unwieldy with the labels here, I know. So as long as you remember that what you're getting is going to be in terms of billions of dollars, then you can fix it up at the end. But if that's going to throw you off, then just stick with your labels throughout here. So then this is going to be, what, 5.7 billion. And we need to divide that by 3. I'll get my calculator here. All right, so that is going to give us, once I can make my arrow here, A will be 1.9 billion dollars. As I divide by 3, it's still going to be billions because 3 divides 5.7, and we still end up with something that's bigger than 1 here. So Amazon's sales are 1.9 billion. Then we have to use that expression that we came up with to find the sales for eBay. So eBay equals that 2A minus 0.1 billion. So eBay will be 2 times 1.9 billion minus 0.1 billion. All right, so 2 times 1.9 billion is going to be, should be 3.8 billion. Yep. All right, so 3.8 billion minus 0.1 billion. And I'm running out of space here, so let me, there we go. And I can continue on here. So eBay's sales will be 3.7 billion. So then we've got Amazon's sales and we have eBay's sales. And that was what our question asked for. Now, if it had only asked for Amazon sales, we wouldn't have to take that extra step and find the eBay sales, but it does want them for both. And supposedly this is actual information from the book. This is one I stole from our textbook. which that surprised me. I figured Amazon, had cornered the market on all of that, but apparently not. All right, so we will flip to the next page where we are going to look at the one in the middle. So page 14 in the middle. All right, 5 times the difference of a number and 3 is 4 less than 4 times the number. Find the number. Okay, so first of all, find my equal sign. Okay, so one side of it is going to be 4 less than 4 times the number. So remember, that's going to be the subtraction where we flip-flop order. So we're going to want to say, 4x minus 4. 4 less, 4 fewer than 4x, 4 times the number. The other side, we've got the 5 times, which is going to tell us multiplication. And then we've got difference of a number and 3. So that is going to tell us subtraction. But because I used the word difference, the one that means an answer to a subtraction problem, it means I already did the subtracting before I want to multiply by 5. So I do need to put that in parentheses. And it'll, since it's just difference, not that less than situation, we're going to put it in directly as it is. So it'll be x minus 3, difference of x and 3. And then 5 times that, so that 5 would be on the outside of the parentheses. So then we have that created, that equation, and we can go through and solve it. So, multiply the 5 through using the distributive property. So 5x minus 15 equals 4x minus 4. And then I think I'm going to move my x's to the left, so I'll subtract 4x from both sides. This will give me x minus 15 equals negative 4. Add 15 to both sides, and x is going to give me 11. All right, so check and see, does that make sense back in my original equation? So 5 times 11 minus 3, is that going to be the same as 4 times 11 minus 4? So 5 times 8, does that equal 44 minus 4? And of course this is 40 and this is 40. So yeah, it does. It checks out with my equation that I came up with. So if you get something that doesn't, that is not a true statement here, then, either you did some arithmetic incorrectly or perhaps you have something incorrect in your original equation. So just use that as a guide to help you know if you're on the right track. All right. Next one is that we didn't do yet is on page 15. And that is the couple purchasing 2 hockey tickets and 2 basketball tickets for $153.92. And the hockey ticket costs $4.32 more than a basketball ticket. Okay, so we get 2 hockey plus 2 b-ball, and that equals $153.92. Dollars. There we go. And then a hockey ticket is $4.32 more, so added to a b-ball ticket. So if I have a basketball ticket and add $4.32 to it, then I'll get to what the hockey ticket costs. All right, so what are the prices of the individual tickets? So again here, I would probably use B for my basketball ticket price. And then I can say that the hockey ticket is 4.32 plus B. And then over here, I can say, all right, well, I've got 2 hockey tickets and 2 basketball tickets. And of course, the basketball tickets, we're just calling B, the price of those. And then it's the $153.92. And then I'm going to use this expression here for the hockey tickets, right? Hockey ticket, hockey ticket. So 4.32 plus B. And that's the building of the equation. We need to go through and use the distributive property. So we'll get $8.64 plus 2b plus 2b